So today we're going to be going over multiplying and dividing rational expressions. Our first question will be a multiplication question. I'm going to go to the next slide, which has the steps that we're going to use for multiplying and dividing. If you want, it might be helpful to just pause the video at this point and read this, or take a screenshot or take a picture with your phone, and then you could always come back to it later. All right, so we already know that our first step is to factor every expression that we see. Altogether, we see 4 expressions. There's a numerator, a denominator, and a second numerator and a second denominator. So for our first fraction numerator, we're going to be factoring by dots, difference of 2 perfect squares, because we have an even exponent, a perfect square, and a subtraction sign, and it's a binomial. Our denominator of our first fraction, we're going to be using the method of AM because it's a trinomial with the coefficient of 1. The numerator of our second fraction, we're going to be factoring out a GCF because they have a greatest common factor between those two terms, and we're going to do the second denominator with the same GCF method. So when we factor the numerator of the first fraction, x squared minus 4, when you factor by dots, that factors into x plus 2 and x minus 2. Remember that you take the square root of everything. So the square root of x to the second becomes x and x. The square root of 4 is 2 and 2. It's helpful to remember that when you're factoring by dots, you always have the same first and second term, but the signs in the middle are opposite. Then for the denominator of the first fraction, we're using AM, which means that we need 2 numbers that multiply to -6 but add to -1, which would be -3 and +2. For our second fraction, the GCF between 3x to the second and 15x is 3x. And when you divide out a 3x, you're left with x plus 5. And for the denominator, the GCF between 6x to the second and 12x is 6x, and you're left with x minus 2. All right, so now the most challenging part of this question is done. Now we just play our matching game. So we match up which factors are the same. You can either go vertically or you can go diagonally and check if the numerator of one fraction has any factors that are the same as the denominator of the second fraction. So I can see by highlighting that I have an x minus 2 and an x minus 2. Those are going to cancel. I also have an x plus 2 and an x plus 2. Those are going to cancel. And the x minus 3 and the x plus 5 does not match, but you also have to remember about your monomials that are left over. So I have 3x and 6x. The x's can cancel, and 3 over 6 reduces to 1 over 2. And then you're left with 1 times x plus 5 in the numerator and x minus 3 times 2 in the denominator. So your final answer, 1 times x plus 5 over 2 times x minus 3. The reason I wrote the monomials, which are the 1 and the 2, I wrote them first. That's usually the best way to write it. Okay, if you have a monomial multiplied by a binomial, you always write the monomial in the front. So we can simplify this a little bit. I don't really need the 1 in front of the x plus 5 because if I distributed the 1, it would still be x plus 5. So I'm just going to make it x plus 5 over 2 times x minus 3. If you want to distribute the 2, you can, but it's not necessary. So either this can be your final answer, Or your final answer can be x plus 5 over 2x minus 6 if you distribute the 2. All right, our next question is division, which is ultimately the same exact thing as multiplication because we're going to do keep, change, flip, and we're changing it into a multiplication problem. So the first fraction would stay exactly the same. That would stay as 24 minus 18x over 9x to the second minus 16. But the division sign would change to multiplication, and then you flip the second fraction. So the denominator would become the numerator, which is 3x squared plus 7x plus 4. And then the denominator would be the original numerator, which is 2x squared plus 2x. So we're going to go in and try to see what method we can use for factoring. First thing we want to check for is GCF, which I can factor out for the numerator of the first fraction and the denominator of the second fraction. The denominator of the first fraction, I would use difference of two perfect squares, also known as dots, and the numerator of the second fraction, I would do the AC method because there's a 3 in the front, because that has a coefficient bigger than 1. So when we factor the GCF out of the first numerator, the GCF between 24 and 18x is 6, and you'd be left with 4 minus 3x. The denominator, when we factor by dots, the square root of 9 is 3, the square root of x squared is x, the square root of 16 is 4. So remember, one gets a plus, one gets a minus. 3x plus 4, 3x minus 4. I'm going to pause on the numerator for a second because that's going to take a little bit of work. The GCF of the denominator of the second fraction would be 2x, and you're left with x plus 1. All right, so the numerator I'm going to write off to the side. So we have 3x to the second plus 7x plus 4. We don't want this 3 in the front, so we're taking it and we're multiplying it to the last number. That's why it's called a C, because you multiply the A term, your middle is the B term, your last term is the C term. You're multiplying A times C, and that would give you 12. So now you're thinking of two numbers that can multiply to 12, but add to 7. A little trick would be to list out everything that can multiply to 12, so 1 and 12, 2 and 6, and 3 and 4, and then figure out which of those three pairs would add to 7, and it's 3 and 4. So now you're going to split the middle. The first term stays the same. The 7x would get split up into 3x and 4x, and then the last term stays the same. So you just split the middle into two numbers so that you could do grouping. So you would group together the first two, the last two, find the GCF between each of these groups. This GCF is 3x. When you divide out a 3x, you're left with x plus 1. Bring down your plus sign. The GCF between 4x and 4 is 4, and you're left with x plus 1. So this is super important. These should always match. If they don't match, then that's kind of an indication that you did a little bit of wrong calculations along the way, and you should check your work. So we're technically factoring out the GCF between these two groups. Your GCF is x plus 1. When we factor out a GCF, it gets canceled, and you're left with 3x plus 4. So that's a bit of work, so I would do that work off to the side. Then this is the answer that gets plugged into the numerator of the second fraction. X plus 1, 3x plus 4. Now we can start canceling. So I see an x plus 1 in common. I see a 3x plus 4 in common. Now, these two are a little bit different. I have a 4 minus 3x and a 3x minus 4. They can cancel, but they're going to cancel out and become -1. So make sure that you multiply in a -1. if I was to plug in a number for x, let's just say x equals 2. If I did 4 minus 3x over 3x minus 4, notice how they're the same binomial, but the terms are switched. So if I plugged in 2, 4 minus 3 times 2 over 3 times 2 minus 4, you would end up getting negative 2 over positive 2, which is negative 1. That's a little helpful way to remember, for you to remember that when you have two binomials that are subtraction, but the terms are switched, they can cancel, but they're going to become negative 1, and that has to get multiplied into your final answer. So we're left with 6 times negative 1 in the numerator, and the denominator is 2x. So there's a little bit more we can do. We have a 6 that's a monomial, and a 2x that's a monomial. The 6 and the 2 can reduce to 3 over 1. So that would become 3. This would become a 1. If you want to save that until the end, you can, but it's good to get into the habit of looking at your single terms and seeing if they can simplify. So then in the numerator, we're left with 3 times negative 1, and in the denominator, we're left with 1 times x. So your final answer would be negative 3 over 1 times x is just x. So negative 3 over x. You can also write it as negative 3 over x. Okay, both of these would be correct. Hopefully this helped. If you have any questions, as always, feel free to message me or email me. All right, guys, good luck studying.